Today we're going to cover section 4. Today we're going to talk about special property or properties of special parallelograms. So today we're going to be talking about rhombuses. So the rhombus, the rectangle, and the square. So these are the three special parallelograms that we're going to talk about today. So first we're going to define what a rectangle, rhombus, and a square are. So all three of these are parallelograms. So notice in the definition, a rectangle is a parallelogram with 4 right angles. So if I draw my rectangle here, so remember the parallelogram looks like this. But the rectangle, as soon as we straighten up the sides and add in 4 right angles, then that parallelogram turns into a rectangle. A rhombus is a parallelogram with 4 congruent sides. So it's still a parallelogram because opposite sides are parallel, opposite sides are congruent, and opposite angles are congruent. But now, as soon as we make all the sides the same, then that parallelogram is a rhombus. And then the last one, a square has everything a rhombus has and everything a rectangle has. So it's a parallelogram with 4 right angles and 4 congruent sides. You're going to need to memorize all of these properties. So all 3 of these have all the same characteristics or properties of the parallelogram, and now we've added in some special features. So the rectangle has everything a parallelogram has in addition to 4 right angles. The rhombus is all the things that a parallelogram has, but it's got 4 congruent sides. The square, everything a parallelogram has, and then 4 right angles, 4 congruent sides. So in tonight's homework, you have a lot of sometimes, always, or nevers. So an example could be, a parallelogram is blank a rectangle, and that would be sometimes. But if I said a rectangle is blank a parallelogram, that's always. So just be careful on the order of the word rectangle and parallelogram or square and parallelogram because it changes it. Sometimes it'll either be a sometimes or it's going to be an always. And then if the question is totally different, it could be a never. So knowing these properties very well are going to help you in those sometimes, always, or never questions. So let's go ahead now. On the next slide, we're going to see these officially as corollaries. So definitions, they're presented as corollaries. So same thing we just said. A quadrilateral is a rhombus if and only if it has 4 congruent sides. So now they're giving us a specific picture. So it says ABCD here is a rhombus if and only if side AB is congruent to BC, which is congruent to CD, which is congruent to AD. They're all equal. Then a rectangle corollary states that a quadrilateral is a rectangle if and only if it has 4 right angles. So this picture of this rectangle ABCD is a rectangle only if and only if angle A is NB and C and D are all right angles. And then the square corollary, a quadrilateral is a square if and only if it is also a rhombus and a square. So if ABCD is a square, if and only if all sides are equal. So AB congruent to BC, congruent to CD, congruent to AD, and angles A, B, C, and D are all right angles. So all squares are rectangles and rhombuses. Square corollary is a combination of both the rectangle and the rhombus. Now, the next slide. So I learned in section 7.1 all these properties of the parallelogram. So I learned first that opposite sides are congruent. I also learned that opposite angles are congruent. I also learned that my consecutive angles are supplementary. And then the last one, I also learned that the diagonals bisect each other. So these are all the properties that we learned back in section 7.1. These are our 4 properties of the parallelogram. Now we also learned the definition, which is already written in here for you, that opposite sides are parallel. So that was the definition, and then these 4 properties were the 4 theorems we learned in 7.1. Now we're going to talk about the special things about a rhombus. So we just saw on the previous slide that a rhombus has 4 congruent sides. We're also going to learn coming up on the next slide a theorem that's going to state that the diagonals are perpendicular. So my first property of a rhombus, we're going to see on the next slide coming up that diagonals are perpendicular. We're also going to learn that the diagonals, a theorem coming up, that the diagonals bisect opposite angles. So I'm going to add this into the picture. So I'm going to go ahead and add in these properties. So I have 4 congruent sides, and then I have the diagonals that are going to be perpendicular. So what I'm going to see is 4 right angles that are formed around this middle here. And then these diagonals also bisect the opposite angles. So this angle is congruent to this one over here, as well as these over here have been bisected. So these are properties of a rhombus. Then we're going to look at the rectangle. We just learned that a rectangle needs to have 4 right angles, and it still has all the properties of the parallelogram. And then in addition, we're going to learn on the next slide coming up that the diagonals in a rectangle are congruent. And now the square that's in the overlap here in the middle of my Venn diagram, it has all the properties of everything. It's got all the properties of the parallelogram, of the rectangle, and the rhombus. So all of these properties are going to like trickle down. So if you think about it, the main name here is quadrilateral. And then from there, it trickles down. So the main name is quadrilateral. I do it like in a flow chart here. Let me fix that. And then from there, it's going to flow to the parallelogram. And then from there, it branches to the rectangle and the rhombus. And then a combination of everything up above is the square. So remember, the square has everything a rectangle has, and a rhombus, which also has everything that the parallelogram has. So all these properties flow down, and everything that's below it has all the properties of the shape above. So all rectangles, rhombuses, and squares are all parallelograms. So now we're going to see these properties that I just filled in the Venn diagram presented as theorems. And then we're going to do some examples. Next. So here we're seeing them presented as theorems. Again, they have names. This is actually theorem 711, but we're not going to memorize the number. So this one is called the rhombus diagonals theorem. And this one states that a parallelogram is a rhombus if and only if its diagonals are perpendicular. And I just wrote that in the Venn diagram. It's also presented in the picture. Notice the right angle here on these diagonals. Notice it's got the property or the definition of a parallelogram. It's got both pairs of parallel sides, or both sides with the parallel marks. Then the next one is called the rhombus opposite angles theorem. It's called Theorem 712 in your book. But again, we are not memorizing these numbers. So it is called the rhombus opposite angles theorem. So a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So here it says ABCD is a rhombus if and only if AC bisects angle BCD and angle BAD, and BD bisects angle ABC and ADC. If you notice in the picture, it's got the congruency marks indicating that those angles were bisected. And then the last one here for the rhombus, it again is called number 713. Again, don't memorize the number. The name here, actually this is for a rectangle. Rectangles, this is called the rectangle diagonal theorem. And this one states that a parallelogram is a rectangle if and only if its diagonals are congruent. So here, parallelogram ABC is a rectangle if and only if diagonal AC is congruent to diagonal BD. And this is all the information that I also put into that Venn diagram. Now remember, all of the above, so all of the above theorems are also true for squares. So all of these also apply to a square. Now we're going to do some examples using all of this new information. We're going to do examples for a rhombus. So they're telling us that this is a rhombus. I just learned that a rhombus has 4 congruent sides. It also has diagonals that are perpendicular. It also has diagonals that bisect the opposite angles. So in order to find ACD, ACD is over here. Let me go ahead and outline it for you. Angle ACD is this angle right here. And I know that in a rhombus, this angle over here has been bisected. So ACD is 62. To find the measure of DEC, I know that my diagonals are perpendicular. So DEC is 90 degrees. For EDC, that one's over here. I can do 2 things. What I'm going to do is focus on this little triangle that was formed down here at the bottom. So if I pull this out, notice what it just created was a little right triangle. And if this angle is 62, to find this missing angle they're asking me to find, the EDC, all I have to do is I know that the acute angles of my right triangle are always going to be complementary. So to find this angle, I'm going to do 90 minus 62, and I get 28. So the little purple angle here is 28. I also know it was bisected, so this side's also going to be 28, because I'm going to need that to find ABC, because ABC over here is the angle opposite. So if these are both 28, 28 plus 28 gives me 56 for ABC. Answering all of this has now enabled me to use all the properties I just learned for a rhombus. Okay, so we learned that a rectangle by definition has 4 right angles. We also learned that its diagonals are congruent. So in order to find the measure of PON is over here. And I know that this angle, by definition, because it's a rectangle, is 90 degrees. To find the measure of PMO, which is over here, I know that this whole thing is 90 degrees. So if I know part of it to be 29, I'm going to do 90 minus 29, and the missing piece here is 61. To find the measure of PL, I know that a rectangle has all the properties of a parallelogram, and I know in a parallelogram, diagonals are bisected. So if this one's 12, this piece over here is also 12 because it was bisected. And now to find the length of the other diagonal, the MO here, I know diagonals are congruent. So if I know in my other diagonal here, this piece is 12 and 12, to get MO, I'm going to add 12 plus 12, and the length of that diagonal is 24. Because I know that diagonals in a rectangle are congruent. So I'm using the fact for these segments that the property of the parallelogram, diagonals are bisected, but when it's a rectangle, they're also congruent. And then the last example will be for a square. They're telling us that quadrilateral MORE is a square. I know by definition the square has all the properties of the rectangle and the rhombus. So it has 4 right angles and 4 congruent sides. So here it says ME has a measure of 7x minus 3 and MO is 6x. I know that all sides in my square are congruent. So to find the measure of x, I'm going to set 7x minus 3 equal to the 6x. Solve for x. Subtract the 7x. Negative 1x equals negative 3. Divide by negative 1, and x equals positive 3. Now, it did not ask me to find the length of the side. It just wanted x. However, in part B, it wants me to find the length of that diagonal. So I know also in a square, because the square has all the properties of rectangles, I know the diagonals in this square are congruent. So if this diagonal, and it's also bisected. So here it's telling me that MT is 4x and TE is 3x plus 2. So I know the diagonals are congruent, so that also tells me that all of these little pieces here are also congruent. So I'm going to set 4x equal to 3x plus 2. I'm going to solve for x. X equals 2. This time they did not want me to find just x. They want me to find the length of OE. And OE is this diagonal right here. So I know it's been bisected. So I'm going to go ahead and plug in 2 into the TE, which is 3x plus 2. So I'm going to plug in a 2. 3 times 2 plus 2 gives me 6 plus 2, which gives me 8. So this little piece right here is 8. So is this piece. So the length of OE is 8 plus 8, and it's 16. So these are all examples using all of the new properties that we learned for our new special parallelograms, the rectangle, the rhombus, and the square.